Hi friends, in this video we are going to discuss about the simple loop analysis of DC generator. Okay, let's see here simple loop analysis of DC generator. In that I am taking, this is the stationary magnetic field, north pole and south pole, and armature. This is my armature which is placed at stationary magnetic field. Of course, the stationary magnetic field flux lines are north pole to south pole. This is like this. And an armature having armature winding which is rotating winding is like this. This is the armature coil. Actually, this is rotating armature coil which produces EMF. We should take that EMF. How it is possible, sir? Actually, it is rotating, right? So the rotating is give the current or EMF to the split rings. This is the split ring 1, and this split ring gives the supply to the brushes. This is brush 1. This brushes gives the supply to the load. This is the load of resistive, as well as here split ring 2 is there. This split ring 2 is connected to again brush B2 which is connected to load. Of course, this is connected to the prime mover which will rotate the armature. Now here the armature coil 1 is connected to slip ring 1 and brush 1, and other coil is connected to, another side is connected to slip ring 2 and brush 2. This is only one armature coil having two conductors. Those two conductors are, first and second is the one conductor, third and fourth is the another conductor. Two conductors are there. This is simply the first. See, what is the EMF induced in the conductors? For example, here my conductors are rotating like this. These are two conductors. These conductors are rotating like this. These conductors are rotating like this. Nothing but here the second conductor is outwards and this conductor is inwards. First and second conductor is outwards. 3 and 4th conductor is inwards. So here the conductor direction is outwards. Motion of the conductor given by the thumb and forefinger direction. And the middle finger indicates the EMF direction. So here the EMF direction is upwards. Here the EMF direction is upwards. So like this. What is EMF direction in second conductor? Ultimately downwards, yes or no? So listen here. Again here the conductor inwards because the conductor is like this, right? So inwards and flux direction is same, but EMF direction is in downwards. So here the EMF direction is like this, like this. See here, my flow of EMF or a current. For example, these are the terminals P and Q, load terminals. So this is generally the flow of current. This is for first half of cycle, nothing but up to this, in this condition. After 180 degrees, this is like this, right? After 180 degrees, conductors rotates like this. So let's go for that after 180 degrees. So this is the north pole and this is the south pole, and here the armature which is placed in the stationary magnetic field like this, which is connected to prime mover. Of course, the magnetic field flux lines are like this. We know this, always the north pole to south pole. And here the armature coils are like this. See, these are my armature coil. Of course, here we have a split ring. This is not slip ring. Split ring 1, brush 1, and split ring 2, brush 2. which are connected to the load. I taken that load terminals as a PQ. This is my load. Now, generally, in first half of cycle, the EMF induced in the armature winding is from 1 to 2, the flow of current is. And the load current is from P to Q. This is from P to Q. In next half of cycle, when this is taken a one revolution after 180 degrees, these conductors will change like this. This is the fourth one, and third, and second, and one. Now 1, 2 is the one conductor, 3, 4 is the one conductor. But here we are using split rings. What we are using here? Split rings. The split rings are splitted here. Nothing but actually here first conductor is connected to slip ring 1, brush 1. But here first conductor is connected to split ring 2 and brush 2. Here second conductor connected to split ring 2, brush 2. But here this conductor connected to split ring 1 and brush 1. Now let's check it. Here again it is rotating like this only. Conductor direction outwards, flux direction, EMF direction upwards, like this, like this. See here, this is given to the split ring given to the battery, brushes, and brushes given to the load. It is like this, like this, like this. This is the way. Observe here, in first half of cycle 1 to 2, in second half of cycle 2 to 1. Nothing but the EMF induced in the armature winding is AC. And here see, in first half of cycle P to Q, even in second half of cycle also P to Q, nothing but the load is DC. That AC is converted into DC by commutator. Commutator nothing but split ring and brush. This is the way of operation in DC generators. Here the power flow is first armature. Actually that armature is given to split ring, that given to brushes, that given to load. Here the EMF induced in the armature is AC, that is given to split ring. But when this is given to split ring, this AC is given to split ring, that gives DC to the brushes. That DC is given to the load. Here commutation process going on. I said you this is the heart of the DC machine. So this is simply the simple loop analysis of our DC machine. They may ask you a question, so the same question I will give you again. A 6-pole DC generator rotating at 1800 RPM, then what is the frequency of EMF induced in the armature, or what is the frequency of armature? Simply, what is the frequency of brush? Brush current frequency, armature current frequency. Like that they will ask you a question. We already discussed about this. The frequency of armature current is 90 hertz. Frequency of brush current is 0 because the brushes carries the DC supply. DC only. In DC generators and DC motors, always brushes carries DC power. So the frequency of brush current is 0, frequency of armature current 120 F by P. From that we can calculate the frequency 90 Hz. This is simply the simple loop analysis of DC generator, which is very important. Okay. Based on this, they will ask you some different questions. Once see here how they will ask you questions. Listen carefully. For example, this is my DC generator, and here itself north pole, and this is the south pole. Is it okay? Right? So here one conductor, here one conductor, here one conductor, here one conductor. Conductor A, conductor B, conductor C and conductor D. My armature is rotating in clockwise direction. They given like this. Then find what is the EMF induced in conductor A, what is the EMF induced in conductor B, what is EMF induced in conductor C, what is EMF induced in conductor D. Before that, we should know what is Q axis, what is D axis. Just brief, I will give you just in brief. Generally, the axis which flows through the pole centers is called direct axis. This is D axis. The axis which is in quadrature to the D axis is called quadrature axis. Quadrature nothing but 90 degrees electrical. This is Q axis. Generally, the effect of north pole is equals to effect of south pole. So on the Q axis flux is 0. If the flux is 0, EMF also 0. If there is no flux cutting, there is no EMF. And so in conductor B and conductor D, no EMF, no EMF. Next. Now tell me, what is the EMF in conductor A? What is the EMF of C? Here, generally, if there is a EMF into the board represents with, tell me, into the board nothing but away from the observer. Away from the observer or into the board represents with cross. Out from the board nothing but towards the observer. Towards the observer represents with dot notation. Into the board, out from the board. Inwards, outwards. So see here my conductor is rotating in clockwise direction. Nothing but this is upward direction and conductor C is downward direction. Armature rotating in clockwise, right? So this is upwards and this is downwards. Where is flux direction? They not mentioned here. How we have to take the flux direction? Always north pole to south pole. This is the flux direction. And this conductor direction upwards. Conductor direction here A conductor upwards, flux direction. Then what is EMF direction? Inwards or outwards? Into the board nothing but cross. The EMF induced here is cross. What is here? If it is a cross, here should be dot, right? Let's check it. Again, flux direction is same. But here the conductor direction upwards or downwards. When rotor is rotating like this, flux direction and conductor direction in downwards. Then what is EMF direction? Outwards or inwards? Outwards. Outwards is nothing but dot. This is the EMF induced in these conductors. Are you getting or not? This is generally they will ask you a basic question. Now, for example, they will ask you another question. See here, this is my conductor. I am taking the two poles are like this. Here, my two conductors are like this, P and Q. And here, this is south pole and this is north pole. And here, this is rotating in counterclockwise direction. Then tell me. Counterclockwise nothing but this is downwards and this is upwards. There is no any confusion. Then what is the flux direction? Don't take like this always. See the diagram. North pole to south pole. So the flux direction is like this. Is it okay? The flux direction is like this. And here conductor direction upwards and EMF direction in this direction. Outwards nothing but dot. And here the conductor direction downwards, flux direction north to south and EMF is into the board nothing but cross. This is another way of question. They may ask you different way of question again. How they will ask you, for example, let's see here. This is my rotor which having north pole and south pole. Here, my magnetic field is rotating in clockwise direction. See here carefully, I am not saying my rotor is rotating. My magnetic field is rotating in clockwise direction. Then what is EMF in first conductor? What is EMF in second conductor? Can you tell me how it is? Very simple. See here, for example, we are sitting in a bus. Actually, I am sitting in a bus. My bus is moving in this direction. Yes or no? My bus moving in this direction. Actually, buildings out of the bus are stationary. Buildings out of the bus are stationary. These are the buildings out of the bus which are stationary. My bus is moving in this direction. My bus is moving in this direction. Buildings are stationary. But once if you assume that if you are stationary, what about buildings? Is the buildings comes with you or away from you? Opposite direction to you, right? Yes or no? So if here, for example, if this is the stationary, if your assumption, then this is rotate in reverse direction. Nothing but now my rotor is rotates in counterclockwise direction. This we have to assume here. Is it okay? Yes or no? Now tell me what is the answer. When this is rotating like this conductor in downwards and this conductor is upwards. So tell me what is the answer. Here flux direction always north to south, downwards, so outwards nothing but dot. And here flux direction north to south and conductor upwards and EMF inwards, and this is the cross. They will ask you questions like this, different questions on the basic rule, Fleming's left hand rule. Actually, this is the question belongs to synchronous motion, because in synchronous motion field is rotating, right? Armature is stationary, right? This question belongs to synchronous motion actually. Like that, they may ask you a question on different ways. Are you okay? Clear up to now? Yes. This is the basic loop equation, loop diagram, and questions on Fleming's right hand rule. Is it okay? Clear? Thank you.